So we have a roller coaster at the top of a loop-de-loop. This question is very much like the question of the object on the string, but now we have different forces acting. So let's take a look here, and I want to be clear on something. Mass is not given, and that's not an accident. Okay, that's actually a deliberate thing. Now, what does that mean in real life? What it means is it doesn't matter whether this roller coaster is 1,000 kilograms or 3 kilograms. The answer to this question is going to be the same no matter what the mass of the roller coaster is. So to this end, let's begin. We want to draw a free body diagram of the situation. Let me assess one more thing. So it says here, this is the trick question. We feel weightless and normal force is 0, but gravitational force is still acting. This is another way of saying it's the same thing as saying what's the minimum speed. It's the same idea, okay? Because when you feel a normal force pushing up on the bottom of your roller coaster chair, you feel like you weigh something. That's what we mean by this. So let's draw the free body diagram at the top. Once again, we'll have the normal force pointing downwards because that's the surface here. Remember, the normal force goes perpendicular downwards from the surface. Then we have the weight of the roller coaster car like this. So when we go around, we're going to have normal plus weight, and the effect is centripetal acceleration on the coaster. This red formula is not given. What would be given is that F net is m times a centripetal, and of course a centripetal is v squared divided by r. Now here, we have 0 for the normal force. We're just barely making it around. We have mg, and the effect of that mg is that it makes the mass accelerate in a circle. Now here's the key. The mass cancels. G is v squared over r. So we're going to isolate v squared as rg. Hey, Mr. Lewis. And then we're going to get v as the square root of rg. So I kind of did a little bit more algebra here, taking the square root of both sides. I'm going to plug in my numbers. So we get 15 meters times 10 under the square root. So v actually ends up being, I don't know, like 12 point something. Let's just see. 12.25 meters per second. All right. And I just want to make one more note here. V is 12.25. I also want to make the note that V squared is 150. I'm going to use this in the next part.